7 is about equations, solving exponential and logarithmic equations. Here we have b to the y equals b to the x. If the bases are the same and these are the same, then the exponents must be the same. Now you can see that by taking log base b of both sides. Log base b of b to the x is x, log base b of b to the y is y, so x equals y. Here we have b to the x equals a. We solve for a by taking log base b of both sides and get x equals log base b of a. This, however, we can use change of base formula. So this equals a ratio of logarithms. Oh no. Oh, this is a mistake. Honk me. Oh. This should be log of a over log b. My mistake. I'm going to change that. 971 log a over log b. I'm going to change that in the canvas. Exponential growth. If P naught is the initial population and P is the future population, and K is the growth rate, and T is time in years, then P equals P naught times E to the KT. Similar is radioactive decay. If R naught is the initial radioactivity of a sample, and R is its later radioactivity, and H is what's called the half-life, how long it takes, which is how long it takes for half of a radioactive substance to decay away, then R equals R naught times 2 to the negative T over H. Whenever T increases by H units, this decreases by 1, 2 to the negative 1 is a half. So that's how this works. All right, here we go. A bunch of examples. 6 to the t minus x minus 2 equals 36 for what x? Well, 36 is 6 to the second power. So therefore, dropping the bases, x minus 2 is 2, so x is 4. That was simple. 5 to the 4x equals 1 over 125 for what x? Well, 125 is 5 to the negative third. So 5 to the 4x equals 5 to the negative 3. Take log base 5 of both sides, and you just get the 4x equals negative 3. Or x is negative 3/4, negative 0.75. (13 to the x minus 1 equals 2 for what x? Well, all right. Now here we have to take log base 13 of both sides. Get x minus 1 equals log base 13 of x, which is log 2 over log 13, common log. Then we add 1 to both sides, and x is 1 plus log 2 over log 13, approximately 1.2702. 2 to the x plus 1 equals 3 to the x. For what x? Well, at this point, the only thing to do is take a common log of both sides, then bring out these exponents, x plus 1 and x down. To get x plus 1 log 2 equals x log 3. At this point, it's basically a linear equation, so we can solve it. First, distribute the log 2. X log 2 plus log 2 equals x log 3. Transpose x log 2 by subtracting from both sides. To get log 2 equals x log 3 minus x log 2. Remove a common factor of x. So log 2 equals x times log 3 minus log 2. Divide by log 3 minus log 2, and you get x equals log 2 divided by log 3 minus log 2. And after some calculation, it's about 1.7095. Three to the 2.9x equals 4.5 for what x? Take natural log base e of both sides. And so this cancels e, power base e on the left, and get 2.9x equals natural log of 4.5. So x equals natural log of 4.5 divided by 2.9, which is approximately 0.5186. Here we have 15 equals 9 to the x plus 2 for what x? All right, we take log base 9 of both sides. You get x plus 2 on the right and log base 9 of 15 on the right and log base 9 of 15 on the left. This on the left is a ratio of common logarithms. Log 15 over log 9 equals x plus 2. Subtract 2 from both sides and get x equals log 15 over log 9, all that minus 2, which is approximately negative 0.7675. Here we have 2/3 to the 6 minus x equals 8/27 for what x? Well, in a sense, we luck out because 8/27 is a power of 2/3, which is the third power. So 2/3 to the 6 minus x equals 2/3 to the 3. We cancel out the bases and get 6 minus x equals 3. So 6 equals 3 minus plus x. So x is 6 minus 3, and x equals 3, and we're done. Here we have 2/3 to the 6 minus x equals 16 over 81 for what x? Well, here 16 over 81 is the fourth power of 2/3. So canceling out the 2/3, you get 6 minus x equals 4. And so 6 is 4 plus x is 6 minus 4, x equals 2. So that's this one. Here we have a half-life problem. Thorium-227 has a half-life of 18.4 days. How long does it take 80% of a sample to decay away? So the radioactivity equals R naught times 2 to the minus T over H. Now R, the radioactivity, is 20% of R naught. The other 80% had decayed away. 20% of R naught equals R naught times 2 to the negative T over 18.4, because that's H. So canceling R naught, 0.20 equals 2 to the negative T over 18.4. Transpose the exponential base 2 via logarithm base 2. So log base 2 of 0.20 equals negative T over 18.4. Transpose the 18.4 and the negative sign to the other side. So T equals negative 18.4 log base 2 of 0.20. All right, now again, log base 2 will be a common log of 0.20 divided by common log of 2. So here you have T, negative 18.4 log of 0.20 over log 2 equals, after calculation, 42.7 days. So that's how long it takes that thorium to decay 80% away. Here's a carbon-14 problem. Carbon dating. Now, the way carbon dating works is that there's a isotope of carbon, I believe 13, which takes about 5,700 years for half of it to decay away. It's constantly renewed in the Earth's atmosphere because of cosmic radiation, which occasionally turns nitrogen into carbon-13. This diffuses down to the Earth's surface. It gets taken up by plants that are eaten by animals. And so as a result, all of us are slightly radioactive with carbon-14. So right, with that, there's its half-life. But of course, when an animal dies, it stops eating, and its bones simply have the carbon-14 slowly decay away. They found a bone fragment 60% with 60% of its initial carbon-14 content. How old is it? All right, so radioactivity is R naught times 2 to the negative T over H. So 60% of R naught, which is how much of the radioactivity remains, equals R naught times 2 to the negative T over 5,700. Cancel out R naughts. 0.60 equals 2 to the negative T over 5,700. Take log base 2 of both sides. Left side is log base 2 of 0.60. Right side, the 2 cancels and just left with negative T over 5,700. Multiply both sides by negative 5,700. It gives you T on one side, and the other side is negative 5,700 log base 2 of 0.60. And again, change of base formula turns this into common log of 0.60 divided by common log of 2. That times negative 5,700. After calculating a bit, you get approximately 4,200 years. So that's how they do carbon dating. Well, I believe that concludes that part.